to the QST YouTube channel. Hope all of you guys are doing well. And today I'll be recording the Term 2 Week 4 Math CA quiz. Let's go. Consider the approximating value of the integral from 0 to 972 over 3 plus x dx using the trapezoidal rule. Fill in each blank with a whole number, dividing the interval 0 to 9 with 3 subintervals of length h equals 3. This is really important. When they say h is 3, or actually, I'm gonna just write out the rule first. The rule using the trapezoidal method is h over 2 into, let's say, I'm gonna call it f1, right? f1. I'll explain what I mean by f1 in part B, if I'm not mistaken, and then plus 2 times, let's say we want f4, right? So f1 plus 2 into f2 plus f3, then we close brackets and we add f4, and then we close brackets. Okay, so h is what we will be skip counting with for each time, starting from 0 till 9. So 0, 3, 6, and 9. And then for here, when they mean f of x is 0, we substitute what we found here in the original function, as we can see here. Like, where was it? Here. We substitute it here, right? So f of x 0, so we substitute x by 0, we get 24. We substitute x by 3, 72 over 6 is 12. We substitute x by 6, 72 over 9 is 8. And then last but not least, 72 over 3 plus 9, 12, which is 6. Now part B is just a simple application of the rule that's written above. So h, which is 3, then f1, which is 24, plus 2 times f2, which is 12. You could do it like 2 times f2 plus 2 times f3, but it's basically distributing this, right? So it doesn't really make a change, but they want it in this form in the quiz. So, and then plus 2 times 12, and then the rest is already filled in. And then for the answer, you just plug this into the calculator and you get 105. You plug this into the calculator and you get 105. Number 2. The diagram below shows the graphs of two horizontal lines and the function f of x is equal to kx squared plus m, where k and m are constant. Point A has coordinates 1, 6, and point B has coordinates 2, 18. Look, so for this question, what we're gonna do first is create a system of equations, right? So we're gonna substitute f of x or y by, let's start with 6. So 6 is equal to k plus m, right? And then 18 is equal to 4k plus m. Now let's subtract here up minus down, so we can cancel out the m. So m cancel. 6 minus 18 is negative 12. K minus 4k is negative 3k. You get k is 4. Done. And then you're gonna substitute in one of the equations. So let's say you got let's substitute it here. You got that k is 4. You're gonna get that m is 2. The shaded region is rotated 360 degrees around the y-axis. The y-axis is gonna come in play later. I'll explain why. Since the y-axis itself is x equals to 0, right? Every time you see the y-axis, right? Like if it's rotated around the y-axis, we're gonna have to interchange, right? To make it x is equal to whatever, whatever. And this also means that we're gonna have to integrate with the, like, instead of using from 1 to 2, we're gonna do from 6 to 18. So let's write the integral here. 6 to 18. And don't forget they're asking for the volume, so we're gonna have to square the function. So here we're just gonna need the function, or y squared. So, oh my god, I'm so sorry guys. We're gonna need x squared. We're gonna need x squared. So the function is 4x squared plus 2 is equal to y. Since they're asking for volume, we can simply get x squared, and that makes life easier for us. So we're gonna get y minus 2 over 4. Then that's all you're gonna integrate. But on the calculator, put it as x minus 2 over 4, so you don't get confused. And then you plug this in. From 6 to 18, we're gonna integrate x minus 2 over 4. We're gonna get 30 pi. Okay, question number 3. Find the values of the improper integrals. Fill in the blanks with the correct numbers. If an integral diverges, enter 999 for your answers. Let's take this. Okay. So first let's set the limits, right? Since here it's infinity, we cannot have that on an integral, so we're just gonna put it as b, right? So the limit as b goes to infinity. Simply what we're gonna do here, keep it like normal, but instead of infinity we're gonna put b and then 1 here, and then 15 times x to the negative 1 over 5, and then just integrate it like normal. So 75 over 4 into x to the 4 over 5 from b to 1, and then again we're gonna limit as b go to infinity. Then we're gonna substitute b by infinity here. So infinity minus 1, which is infinity, times 75 over 4, which is still infinity. They said if we get to infinity or it diverges, in this case, like whether it be positive or negative infinity, just put 999, which is what we got. Part B, let's do the same thing. 8 over x to the 5th root. Hopefully I said that right. Anyways, limit, let's call the one down c. Now look, this is where things get interesting. The limits are originally 0 to 1, right? Ignore that 10, I'm just gonna call it 0. 0 to 1, right? Thing is, Here, can we have 0 in the denominator? No, because 0 will make the function undefined. So what we're gonna do here, I'm gonna introduce a new thing called 0 plus or 0 minus. 0 plus when it's very, 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 very small number above 0. So it's basically 0 it's basically a 0 which allows fractions to be divided by 0. And same thing goes with 0 minus, but it's below the less than 0. Reason why we're going for 0 plus here is because the original limits are from 0 to 1, and that means it should be more than 0, which is why we choose 0 plus. So, and then again we're gonna do like part A, C1 8 times x to the negative 1 over 5. Then we can integrate as always. We're gonna get 10 into x to the 4 over 5 from 1 to c. Now let's substitute x by, so 10 times 1, 1 minus c is basically 0 plus, and then 0 plus is very close to 0, so 0 times 0 to the power of 4 over 5 is just going to be 0, so 1 minus 0, so 10 times 1 minus 0 is simply 10. Number 4. This one is not bad, not good, but we had it last week and I hope you guys understood. In the diagram below, the region is bounded by the curve y is equal to radical x and y is equal to 1 over 3x. If the region is rotated completely around the x-axis, which is when we don't need to change anything, the volume of the generated solid. Now look, here, since we have two curves, a line and a curve in this case, we're gonna need to find out, so now the rule will be pi into, just say a and b are the limits. I'll call the farther one big R, then then the farther one from the axis small r, right? So here, the farther one from the x-axis is the curve, so radical x. So pi into, from 0 till 9, radical x squared minus 1 over 3x squared. Now you may ask, how did you know that the radical x is the curve? This is, okay, to be honest, it's pure logic, but like when it's a line, it's just gonna be 1 over 3x, like ax plus b, which is the slope form equation. And for a curve, it's like, it could be exponential, could be power of, anyway, you're gonna plug this into the calculator. Again, pi into from 0 to 9, the integral of radical x squared minus 1 over 3x, all of it squared, which is 13.5 pi. Now for part B, which is the tougher part, If the region is rotated completely about the y-axis, then the volume of the generated solid. So now we're gonna do what we did in the first question, right? We're gonna have to, like, how can I say it? We're gonna have to isolate x. So here it will be y squared. Then we take 1 over 3x to the other side, we'll get 3y. And now see, here is an issue that I honestly faced before I started recording. I was saying, how how do I get the big R small r? So what I figured out is that you could substitute any point in between the limits. So in this case it would be 0 and 3, right? Since we're using in terms of x, we're gonna interchange, so we're gonna use y as the limits. So the limits are 0 between 0 and 3. Just take a number in between and substitute. So let's take 1. So 1 here and 3 here, which means 3y is larger. So now we're going to integrate pi times from 0 to 3. Again, same thing, 3y squared minus y squared squared. We plug this into the calculator. So pi times from 0 to 3 again. 3x all of it squared. You could use x, which is what I'm doing on the calculator. Instead of y, you could use x. Only on the calculator, no, do not do it in the question. So minus x squared squared, which is x to the 4, which is 32.4 pi, which is the answer. Number 5. Evaluate each improper integral and fill in the blank with the correct integer. If the integral diverges, enter 999 for your answer. Okay. Here we're going to do the same thing as the other questions that we saw, similar to this. So let's make it smaller a bit so you can solve. And then let's start. The limits from b to infinity. So b here, 1 here, then x to the negative 1 over 3. We're going to integrate and get 3 over 2 into x to the 2 over 3 from b to 1, 1 to b. So we're just going to get infinity to the power of 2 over 3, which is infinity, minus 1, which is infinity, times 3 over 2, which is also infinity, which is how we got 999 here. Part B. This part is slightly confusing, especially with the signs, but once you get used to it, you'll know how to solve it. Again, limits from b to infinity. Then we're gonna integrate from 1 to b, 14 into, what we're gonna do is add 4 plus 1 over 2, since radical x is x to the half. We're gonna get 9 over 2, take it up, it will become 14 times x to the negative 9 over 2. then integrate. So 14 times negative 2 over 7 into x to the negative 7 over 2 from b to 1. Negative 2 over 7 times 14 is negative 4. Now look, as we know, when we evaluate, we're gonna substitute b by infinity, right? And we're gonna have, in this case, 1 over infinity to the 7 over 2, which is, of course, 0. Since infinity is a large number compared to 1, which is a small number, we're just gonna say it's approximately 0. So 0 minus 1, obviously, times negative 4. So negative 4 times negative 1 is 4. We're finally done with this question. And let's move to number 6. Don't tell me there is more. Evaluate each improper integral and fill in the blank with the correct integer. Then again, we're gonna solve as always from, so we're gonna integrate from, first we're gonna need to set the limits, right? Since we cannot have 0 in the denominator here, we're gonna, from 0 to 1, we're gonna take a number between that, which will take as 0 plus, limit as c goes to 0 plus, so c down, 1 up, x to the negative 6. We're gonna integrate and get, again, limit from, as c goes to 0 plus, we're gonna get negative 1 over 5 into x to the negative 5 from 1 to c. So negative 1 over 5 times 1 minus infinity, which is infinity again, right? Because here we'll get negative infinity times negative 1 over 5, which is positive infinity, which is how we got 999. Part B. Let's shrink it a bit. And okay, so limit as c goes to 0 again, 0 plus, sorry, integral from c to 8, x to the negative 1 over 3. We're gonna integrate, we're gonna get 3 over 2 into x to the 2 over 3 from 8 to c. I'm not gonna put the limit, it's gonna waste some time, but you know what I'm gonna do. So 3 over 2 into 8 minus 0. Wait, it's not 8 if I'm not mistaken. It is 4, sorry. Because if we substitute 8 to the 2 over 3 is 4. So 4 minus 0. And then we're gonna get 4 times 3 over 2, which is 6. Number 7. The region bounded by the lines 3x, y equals 9, and the x-axis is rotated completely about the line y equals 10. So this time it's not the x-axis x-axis or the y-axis. It's a random line which is y equals 10. First, let's find the limits. Here they set the y-axis, which means we already know we start from 0. Then we equate from 3x equals to 9. We get x is 3, right? And then here to find big R, small r, which is slightly annoying, as always. So 3x, 9, and 10. What we're gonna do is we're gonna do 10 minus this, 10 minus, so 10 minus 3x and 10 minus 9. So 10 minus 3x and wait, 10 minus 9, which is 1. Wait. Yeah. 10 minus 9, which is 1. And then let's substitute a number between the limits in one of these two so we can figure out which one is big or small r. Let's take 1. So here we get 7, here we get 1. Of course 7 is bigger, so we're gonna take this as big R and then 1 is small r. So we're gonna do 10 minus 3x squared minus 1 squared. Sorry for wasting your guys' time. I'm gonna plug this into the calculator. So give me a minute. So pi into, from 0 to 3, 10 minus 3x, all of it squared, minus 1, which is 108 pi. Number 8. Okay, the diagram below shows a part of the curve 1 plus 4x to the half and a point A 2, 3 lying on the curve. The line AB intersects the x-axis at 5, 0. Look, let's split this into two parts, right? So this part, as we can see, is split by the curve, right? The one in blue. Then the one in red, this one, is cut by the line, as we can see here. Now look, for situations like this, what we're gonna do, now I'll tell you why they told us to use the volume, right? So when we're gonna use the line, when we are finding the area under the graph with a volume, my bad, volume under the graph, since they're asking with cubic units and volume here, since they want the volume under the graph, we cannot integrate, of course, right? Because we do not have, because first of all, we do not have the, I know we can find the line easily by doing the slope, but that is not, it does not seem as simple as that. That's all I'm gonna say. Okay, so first of all, what we're gonna do, since here we have the curve, right? We're gonna, for the first part, we're just gonna integrate the function squared times pi, right? So 0 to 2 pi. The function squared is just gonna be 1 plus 4x. Simple as that. Plus now for with the line, we're gonna use half, I mean 1/3 times 1/3 pi r cubed, pi r squared h. So this is where this comes into play. Height, or h we're gonna say, is horizontal, so from 2 to 5. Then the radius will be the vertical, so from 0 to 3. So what we're gonna do is 1/3 pi r, which is 3 squared 9 times the height, which is 3. So we're gonna plug this into the calculator as well. I'm really sorry for not memorizing the answers beforehand. From 0 to 2, we're gonna integrate the function squared, which is 1 plus 4x in this case, plus 1 over 3 times pi times r squared times height, which will give us 19 pi, which is correct. Number 9. Okay, first of all, from what I have seen, this is not the answer. So I'm just gonna, I can. Okay, the correct answer is positive infinity, and I'll explain why. So first I'm gonna grab this, right? And they also gave us the negative 12 over radical x plus c, which is the given here. Amazing. Oh, wait, I forgot to add it to the old page. Amazing. And bring this, add to current page. Perfect. Perfect. Then I'm gonna add the options. Previous. Just gonna keep it like this. So here we want from 0 to 1. We already have the function itself. All we need to do is to change the limits here, because there is 0. Just gonna put limits as c goes to 0 plus. خلاص, negative 12 into 1 over radical x, then close the brackets from c to 1. Okay, now we have negative 12 into 1 over radical 1, which is 1, minus c, which is 0 plus. 0 plus, right? 1 over 0. 1 over radical 0. So 1 over 0. 1 over 0 is infinity. So 1 minus infinity. So this will give you negative infinity, right? And then negative infinity times negative 12, which is going to give us positive infinity. Part B. Wait, I'll just bring this to the current page. Oh. And I'm also gonna get the given. Oops. Okay, gonna add this as well. Add to current page. And once again, let's do the same thing. Limit as b goes to infinity. So we're gonna do negative 12 into 1 over radical x from 1 to b. So 1 over radical infinity is infinity, right? So 1 over infinity is 0. 0 minus, then of course don't forget the negative 12 here. 1 over radical 1 is 1. So negative 1 times negative 12 is equal to 12, which is the right answer. This question, when The integral of from negative 6 to negative 3, 10 over 1 plus x dx is estimated using the trapezoidal rule with n equals 3. The estimate is k over 3, where k is a whole number. Look, to find the height, it's the same as the first question if I'm not mistaken. So height, how do we find it? We're gonna do b, which is negative 3 in this case, right? B and a being the limits. So b minus a over n. So negative 3 minus negative 6 over 3 is 1. So the height is 1. And then let's make the table. So we're gonna skip count from negative 3 to 6 by 1. So negative 3, negative 4, negative 5, negative 6. And then we're gonna substitute negative 3 in the equation itself, which is 10 over 1 plus x, right? So 10 over negative 2, negative 5, 10 over 10 plus 10 over 1 plus negative 4, which is negative 10 over 3. Wait, let me just keep the height as 1 because we'll need it in the rule. Then let's substitute x by negative 5. 10 over 1 plus negative 5 is 10, negative 10 over 4. Then we're gonna substitute by negative 6, which is 10 over negative 5, which is simply negative 2. Then simply what we're gonna do is the rule. Height over 2 into negative 5 plus 2 times negative 10 over 3 minus 10 over 4 close brackets minus 2, and that will get us negative 28 over 3. Number 11. A continuous function f has the following values. Use the trapezoid rule. Okay, this is simple. We're just gonna apply the rule. The height in this case is the number we're skip counting with. So what we're gonna do to find the height is 1.2 minus 1, which is 0.2. And we're just gonna do the rule. 0.2 over 2 into 0.7 plus 2 times 0.6 plus 0.5 plus 0.4 plus 0.3 close brackets plus 0.2. We're going to close this big bracket and we're gonna get 0.45. That's it for today's video. Thank you guys so much for watching this video, and we wish you guys the best of luck in all of your future exams, and goodbye.